on the screen here, I've got on Desmos, I've got just 2 points plotted. So the point -1, comma 7, and the point 3, comma 4. So what we're going to look at is what is the distance between those 2 points. Now, it's always easy to find the distance between 2 points that are either connected on the same line horizontally or vertically, but we have this diagonal here. And so with the distance formula, what we're really doing is we're going to use the Pythagorean theorem. So the distance formula, we've got d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And one of the big issues with the distance formula is that it's really messy. Okay, it looks super complicated. The great thing about the distance formula is that if we're really thinking about it and looking at it, this all comes from the Pythagorean theorem: a squared plus b squared equals c squared. So basically what we've done in order to get to the messy distance formula is to find A, we've looked at the the difference between our x values, and to find B, we've looked at the difference between our y values. And then ultimately we want the distance, we don't want the distance squared, so that's why everything is underneath the square root. So we'll switch back to Desmos, and so I just draw in a right triangle. I've got this vertical line and this horizontal line. Okay, and so sometimes if you draw out the points, a lot of times in a math textbook, you're just given, okay, here are 2 points, just the numbers. But sometimes drawing it out so that you can actually see what this looks like visually can help you with it. Okay, and when you draw it out, you can see that the lengths of our the legs of our right triangle pretty easily. The length of vertical leg is 3. Just go down 1, 2, 3, and the length of the horizontal leg is 4. We go over to the right 1, 2, 3, 4, and so it's pretty straightforward. And it's one of the reasons I chose this set of points is this is a 3, 4, 5 triangle. So our distance is 5. Okay, so let me show you the math on the iPad. How we would plug this into the formula, and then we'll go from there. I'm plugging in. I'm looking for the distance. It's all going to be under the square root, and I'm going to find the difference between my x coordinates, and once again, the coordinates were -1, comma 7, and 3, comma 4. So I'm going to do my x coordinates first, and it doesn't actually matter with the distance formula what order you do the subtraction in, because ultimately you're going to end up we're going to be squaring the value, so we'll always end up with a positive value. So I'm going to take my x coordinates. I'm going to do 3 minus -1, and we're going to square that. And I'm going to add to that the difference in my y coordinates, which is 4 minus 7, and I'm going to square that. So you can try to set it up always so that you always end up with a positive value in there, but once again, if we look at the second one with the y values, 4 minus 7 is -3, 7 minus 4 is +3. Either way, when we square it, we're going to get 9. So for my distance, remember 3 minus -1, that's like 3 plus 1, so that's 4. And 4 minus 7 is -3. And so we get the square root of 16 plus 9, which is the square root of 25 which is 5. So our distance works out really nicely. We just get a distance of 5. All right, so I'm going to pick 2 points. I'm going to pick the point 2, 5, and the point 7, negative 2. Okay. Now, if you want, you can draw this out. Once again, draw in your triangle, get the lengths of the legs there, and find the hypotenuse. I'm just going to go straight into the distance formula here. So for the distance, I'm going to take the x values. So 7 minus 2, I'm going to square that. I'm going to take the y values, negative 2 minus 5, I'm going to square that. And then I'll take the square root of that sum. So 7 minus 2 is 5. Negative 2 minus 5, that gets us negative 7. And then we'll square both of those. So I get 25 plus 49. And we can add those values together. 49 is really close to 50, and we know that 50 plus 25 is 75, so this has to be 74. That's review of the distance formula.